Parker and Sophie fill buckets with water from the same well. They each, that's very important, they each, like so each of them fill up their own 15 buckets. Each fill up exactly 15 buckets to capacity and pour all the water into a second well. Sophie then uses her original bucket to independently pour the water back into the first well. If it takes exactly 25 full buckets for the water to reach its original level, the size of Parker's bucket is what fraction of Sophie's? Okay, so kind of a tough problem. It's imperative that you notice that each fill up exactly 15 buckets. So Sophie's using the same bucket when she refills the well. So the 15 buckets that she originally put into the second well, they're going to cancel out 15 of those buckets that she puts back into the first well, right? So she took 25 full buckets. They're going to be canceled out by 15 of those buckets that she originally put into the second well, right? So, so it took her 10 buckets to replace the water that 10 buckets to replace the water that Parker took out of the well with his 15 buckets. So 10 buckets of Sophie's or 10 full loads of Sophie's bucket filled up the same amount as Parker's 15. So if it's 10 buckets of Sophie's over 15 buckets of Parker's, Parker or Sophie, that's 2 over 3. So Parker's bucket is 2/3 the size of Sophie's. It's a little bit tough to kind of pick up the right clues in this question, that they both filled it up and that these 15 buckets that she put from the first to the second well are going to be canceled out by the ones that she took from the second to the first well. Then you just notice that it's 10 buckets to get it back to where it was. That means it took 10 buckets to fill it back to where Parker's buckets were taking out, and then it's just the simple fraction of 2 over 3. Okay, let's go ahead and confirm that. We're good, and we can move on.